All right, let's talk about doing some lookups that are two-dimensional. So when we did our other video, we looked at the properties of saturated steam, which is going to have the pressure and the temperature together. So you're very successful at taking the temperature as input and finding the density and the specific entropy as a function of one or the other. Well, this is only for saturated steam. Let's say we have data for steam that is superheated above saturation as an example of data that's going to have two independent variables governing the data structure rather than being one driving variable. So again, we'll just grab the table off the engineering toolbox, copy, and paste that into Excel. Alright, so this time we're going to be feeding it two inputs, input 1 and input 2, where we're going to have to distinguish between the two different values for pressure and temperature, right? So let's say we're going to be looking at, I don't know, 500 kilonewtons per meter squared, which is 5 bar, right? Because a bar is 100 times larger. And input 2, 200 degrees Celsius, right? Pressure. This is kilopascals. Assuming I can get this. No, got caps lock on. kPa. Right, third time's the charm, fifth time's the charm, and degrees C, right? So we got two inputs. Now, we're going to be getting those, doing some match functions again, right? To get some row indexes. So we're going to be matching input array, and then we'll just look at an exact match for now, right? Okay, sixth position down, 1, 2, 3, 4, 5, 6. There we go, 6, right? And same thing for temperature. $200, and then the temperature across is like there, right? All right, and another exact match. Fourth position across, 1, 2, 3, 4. Right, 200 degrees. All right, so far so familiar. Well, let's talk about putting those together so we can do the lookup on this right triangular data. And this is where we're going to be feeding index with 3 arguments: array, row number, and column number. So the first value here, rather than being a one-dimensional array again, that we're going to be feeding just a row number, we're actually going to be feeding a two-dimensional array, a table with 2 arguments, row number, so the number down, and column number, the columns across, right? 3 arguments there. Well, there we go, 7.059. So we got 500 going across, 200 down, 7.059. See? So we can look up for 2 directions on our index and then feeding it 2 matches. So if we stick all of them nested together, then you can see everything all at once. We have our table of data, and then we have the first match for row position, feeding that as its first index. Oh man, I'm just on top of these keystrokes, aren't I? And then the second one, which is going to be the column position across there like that. Now we close off index. There we go, 7.059. So in all our glory. So a two-dimensional lookup then is going to be taking about 7 arguments from you as input, 5 of which are going to be references. So index is going to be taking the table of output data, and then you're going to be feeding it 2 matches, each with 3. So that's 3 plus 3, 7 inputs, 5 that are arguments, right? First match is going to be the row number, so the number of rows down. So we have some lookup array, and then the input we're looking it up into, and then we're going to be giving it whether it is an exact or approximate match. And then we're going to be doing the same thing going sideways. So we'll be feeding some input into an input array and then getting how many rows over that is. And again, exact versus approximate match. There we go. Specific entropy. Assuming I ever spell things correctly. So that's how you do a two-dimensional lookup with index match. You can do it with VLOOKUP, but the way you do that is by feeding it this whole table, right? That first row has to be your input range for I'm getting all mixed up. First value, lookup value, the whole table of data, and what you do is rather than just feeding it a column index number, you feed it a match, right? And then because we're actually going to be 2 rows over because we got these other 2 values here, you're going to have to be doing your match plus 2. And honestly, if you're putting a match in a VLOOKUP, you might as well just use index, right? Alright, so that's going to be a two-dimensional lookup using index and match. Now you'll notice that that was for an exact lookup, right? So if you're trying to get in the middle there, well, then you're going to have to be doing, we're getting a not applicable, right? Because we're getting 559. Well, that's not any of these values, so you got a not applicable, and then that's getting fed into your index, so that error is matriculating through to just stay that NA value, right? So if you're going to be doing an index match on a property table, rather than just doing a data lookup in some kind of SQL table or whatever, if you're doing a property lookup, then you're going to have to run a double interpolation or maybe a single interpolation, and that's going to be a more complicated function, right? But getting back to just the basics of it, you got index match for one-dimensional, and then index with 2 matches in it for a two-dimensional lookup. And if you understand how index and match work, it's pretty simple to go up to this next step. Alright, thanks for your time, everybody.